All right. We'll continue. Should be the last part. That's some technical difficulties. I apologize for getting cut off. So looking at this problem number, what is this? 9. The score on the test and the number of incorrect answers on the test. All right. So when looking at this, we can think of an actual scenario, right, in class. So I'll explain it this way. Looking at here, it says your test grade or your score. So we have the test score and the number of incorrect questions. Now, again, looking at a scenario, you just kind of have to sit here and, you can try to do what I'm doing and try to make it, a little more complex, but nonetheless, it'll help us think critically, right? So, looking at this test score and the number of incorrect questions, right? Well, again, taking your information from your test, right? Like your normal test scores, right? We know we start out with 100, right? So, if you want to sit here and make a little table, right? Actually, we'll make it a little more realistic. We'll have the score and the number of questions incorrect. So incorrect and the score, right? So what happens if you miss zero? Well, notice how that is a 100. Pretty obvious, right? But suppose that you have, I don't know, 100 question test. Let's just go with basic, right? Let's have a 10 question test. If you miss one, your grade is a 90. If you miss two, your grade is an 80. If you miss three, your grade is a 70, right? And so forth. Now remember, what is the situation here? What are they asking us? They're asking for a direct variation. Tell whether the scenario is a direct variation. Remember, direct variation means that we have a formula that can be represented like this, and something also special about this is that we have a constant variation which says for any output and input, for any coordinate point, we must have the same ratio. When we look at this, I'm going to take this point out of, I'm not going to use it because we're dividing by zero, which is a big no-no, but I'm going to use the other points, right? Notice how here we have 90 over 1, 80 over 1, 70 over 1. Notice how these are all different ratios. This is 90, this is 80, this is, oh, I'm sorry, divided by 2 here. It's actually 40. Divided by 3 here, which gives me 3, what is this? 2, 23.33. And this was 40. Sorry about that. 40, 40, 40. So as you can see, the ratio of y to x for each point is not the same. So because the ratio for these points are not the same, this is not a direct variation. Not a direct variation. So when we go to our answer choices, you can also look at the other cases, right? Like suppose we don't want to go through what I just did. We can actually read, right? So is this a direct variation? No, because it's, well, let's look at the choices. It says when one quantity increases, the other does not increase. Now notice how it doesn't say the other doesn't go down. It just says the other doesn't change, which is not correct. If my score, or rather, if the incorrect questions goes up, my score is going to get lower. B does not say that. C, when one quantity increases, the other also increases. That is incorrect because we just said if you get more wrong, your score is going to go down. So it cannot be C. No, they do not directly vary, which is both A and D are good. But now look what it says. When one quantity increases, the other quantity does not increase. Now again, we know the other quantity decreases, but we don't know about the other scenario. In this case, no, they do not vary directly. When one quantity increases, the other quantity also increases. D cannot be it because, again, we just said when one increases, the other does not increase. It decreases. So in this case, I'm going to go with A. This is a terrible problem. I apologize, but yeah. Problem number 10. Graph the direct variation. Pretty straightforward, right? We have a graphing calculator. Again, don't forget, whenever we see this, just go to on, new document, and just go to graph. hit no, and then go to graph it, we start fresh, right? Again, the problem says, student, can you graph this direct variation equation? Why is it direct variation, as you guys saw in the notes? Because it starts at the origin, right? It's y equals kx. It follows that form. So again, in my calculator, I'm going to type in y equals kx. Y, which is f of x, they're interchangeable, equals 9x. Hit enter. Here it is. Obviously, my window is not to where I want it to be, but it's okay. I can use my table. Menu, table, split screen. And now we have some points to use, right? We know that, as I just said, any direct variation starts at the origin, and just pick one more point. In this case, I'm going to use the point 1, 9. When x is 1, y is 9. So I'm going to plot those 2 points. So here, again, I'm using the line tool. It starts at the origin. Notice how this point was 0, 0. Right here. It should be 0, 0. There it is. That's the origin. That's what's special about direct variation. My second point was 1, 9. There it is. Save. Check. There it is. And last but not least, problem number 11. Problem number 11 says, the distance d you bike varies directly with the amount of time you bike. All right, so now again, varies directly, y equals kx, but now they're giving me variables. Distance d, time t. Now again, if you've been in class, if you paid attention, you can already tell t is my independent variable. This is the x because we know time and what's coming up. The distance, dependent variable, depends on time. That is why this is a dependent, independent. Now it says, suppose you bike 14.8 miles to 1.25. Oh, Jesus, I'm sorry. Suppose you bike 14.8 miles in 1.25 hours. Right? So that is very important. So I'm going to write this down on a piece of paper. First fact was I'm given a direct variation, which is y equals kx. And it says my distance was 14.8 miles in 1.25 hours, right? So it says write an equation that relates d and t, and what is the graph of the function. So, important information given here, right? This is it. They first told me, hey, you have a direct variation, and then I can come up with my equation, right? It said d, distance, varies directly with respect to time, k, t. Notice how this is my equation. Again, why is it d times kt? What's it? Distance varies directly with time. Distance varies directly to time. There it is. See, that's how I got the equation. Distance varies directly with time. So it said write the equation. Well, remember, the nice thing about this is how do we find k? Well, k is the output over the input. In this case, distance over time. There should be an x. Sorry about that. So they gave me some information here. The distance for 14.8 miles in 1.25 hours. So I biked 14.8 miles in 1.25 hours. Punch this in your calculator. I'm going to get, again, go to this, 14.8 miles divided by 1.25. Again, this is terrible. So I get a constant variation of 11.84 miles per hour, right? That is my constant of variation. So it said, hey student, can you write an equation? Well, yeah, there it is. So from the given information, I found my constant of variation, 11.84. So again, this is what I'm going to use for my equation. Now again, remember, time and distance are variables, input and outputs. My equation is just me finding the value of k. So the equation is y, or I'm sorry, not y, distance is equal to my constant of variation, which is 11.84 miles per hour, right? Times time. 11.84 times t. I'm going to go to the homework. 11.84 times t. Again, you can also just plug some of these values in, right? You can use each one. You can plug in time. We know we biked an hour and 25 or 1.25 hours. Plug it into each one and see which one gives you 14.8. So again, in this case, the answer is B. Now it wants you to graph it. Now again, you have a handy dandy calculator. You can graph it. What you have to be careful with is just be careful with the graph. Notice how these graphs go from 0 to 5 and they go 0 to 30. Right? So if you're going to use your calculator, keep in mind this is not going to be the same as your calculator. So 11.84, and again, just to show you, I will put this here for you. I'm going to go to graph. Again, it was 11.84. First of all, notice how this is x. So in my graph, it said time, right? This was t, but I'm going to use x because this calculator, as you can see, has a variable of x, right? So don't get that confused. Again, it is a very steep line. I will show you something nice with the calculator. Again, notice how this goes from 0 to 5 and 0 to 30. I can actually change my window on the calculator. If I double click this here, I can go to 30. If I click this here, I can go to 5. And there it is. Here I'm going to go to -1. And this one I'm going to go to -1 as well. And there it is. You have a clear view of what my graph looks like, right? 0 to 5 and 0 to 30. So it is a line that is somewhat steep. So when I go to my graph, my answer would be Charlie. Now, again, all of these can be good candidates, but again, make sure that you're looking and paying close attention, right? Is it C? There it is. All right, all right. Again, be very careful. Notice how C and D look very similar. Right, so again, make sure that you're blowing this up and actually check the points, right? So again, here, this at 1 second, it would be at about maybe 15, 16. So again, be very careful. Make sure you guys are checking the correct boxes. All right, there it is. That concludes V2. Again, make sure you're looking at the notes and the examples, please. All right, all right. See you next time.